Welcome to today's video. Today we are starting systems of equations, and we are going to start by graphing the two lines and identifying the point of intersection. Again, we want to be able to demonstrate mastery by scoring 80% on an exit ticket, which you will take in class tomorrow. Hopefully you have the notes in front of you. If you don't, take out a piece of paper. You can take the notes on there. If we look, first of all, a system of linear equations in two variables is at least two linear equations in those same variables. Now, we can have three different types of solutions. We can have one solution, which is where the slopes are different and they intersect at one specific point. We can have no solution, where our slopes are the same, but our y-intercepts are different. That means these lines will never intersect and they're going to be parallel to each other. Or we can have infinitely many solutions, which means both our slopes and the y-intercepts are the same. They are exactly the same line. They just lay on top of each other. So they are the same, meaning they have infinitely many the same points. Now, if we look, when we talk about graphing, we want to make sure we're in slope-intercept form. If we look at example 1, our first two equations are both in slope-intercept form already. And just as a reminder, in case you forgot, slope-intercept form is y equals mx plus b. So I'm going to graph the first line, y equals x minus 8. Well, I'm going to start at my y-intercept of negative 8, and I'm going to put my dot. Now, I have a slope of 1 in front of this x, so I'm going to call it 1 over 1, and it's positive. So I'm going to go up and over, up and over, up and over. And we're going to keep doing this until we cannot put any more dots on the line. We don't want to stop after 2. We want to make sure we do all of them so that we can find that point of intersection. I'm going to connect my line. And that is my first graph. I'm going to put a red dot there so I know that that's that graph. So now I'm going to graph my second equation in y equals mx plus b form, or slope-intercept form. I have a positive 1 as my intercept, and now I have a slope of negative 2, and I'm going to put it over 1. So I'm going to go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And again, we're going to continue this until we can no longer do any more. Now, we could also go positive 2 to the left 1, because that still gives me a negative slope. And if I connect all my dots, there is the line of my second equation. Now, if we look, this tells me that this graph has one solution. Well, my solution is exactly where these 2 points hit, which if we look, is positive 3, negative 5. One thing to keep in mind is your solution, if you have one solution, is always going to be written as a coordinate point, x, comma, y. If we look at our second problem, again, to be able to graph the lines, we have to be in slope-intercept form. So I'm going to take my standard form of x plus 3y equals negative 15, and I want to turn it into slope-intercept form. So I'm going to start by subtracting my x. I have 3y equals negative x minus 15, and then I'm going to divide all my terms by 3. So y equals negative, excuse my board there, negative 1/3 x minus 5. Now that I have it in slope-intercept form, I can graph it. So I'm going to start at my y-intercept of negative 5, and I'm going to go down 1 to the right 3, down 1 to the right 3, and then I'm going to go up 1 to the left 3. Still gives me that negative slope because now I'm going positive 1, but I'm going to the left, which gives me my negative. And apparently my board does not want to do a straight line there. Connect your points. Hopefully it's a little straighter than mine. Now we're going to graph our second equation, which is y equals negative 7. Well, if I graph negative 7, it is a HOI, or a horizontal line. Hopefully it'll make a decently straight line. And if we look again, I know it's kind of hard to tell because of this wonderful board, but these two graphs intersect at exactly 1 point. So we need a coordinate pair as our solution. Makes our coordinate pair 1, 2, 3, 4, 5, 6 on the x, and we go negative 7 on the y. So again, exactly one solution. If we look at example 3, again, we want them in slope-intercept form. Well, our first example is not, so I'm going to take x plus 2y equals 4, and I'm going to turn it into slope-intercept by subtracting x on both sides. Well, now I have 2y equals negative x plus 4. Now I'm going to divide all my terms by 2, so I get y equals negative 1/2 x plus 2. Now that it's in slope-intercept form, we can graph it. So I'm going to start at my y-intercept of positive 2, and I'm going to go down 1 to the right 2, down 1 to the right 2. I'm going to continue that. Now I'm going to go up 1 to the left 2. Again, we want to keep doing this as many times as we can, and then connect our points. Now we're going to graph our second equation. It's already in slope-intercept form, so I'm going to start at my y-intercept of, positive 2 again. And it's negative 1/2, down 1 to the left, down 1 to the left. If we notice, every single point falls on that line. These two equations are the same equation, so there is infinitely many solutions. The lines fall right on top of each other. For example 4, our first equation is already in slope-intercept form, so we can start by graphing that. I'm going to start at positive 5, and I have a slope, since there's nothing there, of 1 over 1. So I'm going to go up 1 over 1, up 1 over 1. I'm going to continue that down 1 to the left 1, because negative divided by negative gives me a positive. If I look at my second equation, it's in standard form. It's not in slope-intercept form. So I'm going to turn it into slope-intercept form by subtracting x on both sides. I now have negative y equals negative x plus 2. And now I'm going to divide all my terms by negative 1. I'm going to be y equals x minus 2. So I'm going to start at negative 2 as my intercept. And again, I have a slope of positive 1, so I'm going to go up 1 to the right 1, up 1 to the right 1, and I'm going to continue. And then I'm going to go down 1 to the left. If you notice, these two lines never intersect. They have the same slope, but they have different y-intercepts. In this case, because they are parallel and never intersect, there is no solution to these two equations. They will never intersect. Hopefully, watching this, you have a pretty good understanding of what we're going to be working on in class tomorrow. Make sure to refresh your memory with these notes if it's been a while since you've looked at them. Come to class tomorrow prepared to learn. I look forward to seeing you then.